I'm Kobie Crawford. I'm a developer advocate at Databricks, and the title on the deck is accurate. I had an opening where we were going to talk specifically about MLflow, and we actually are going to talk about MLflow and the agent framework as sort of an answer to a broader question. But I've got this talk set up in a way where what I'm trying to set up here is just sort of to give a level set for people. Like if you've come in, I didn't have a really solid sense of like exactly where the audience was going to be in terms of like their pre-existing knowledge. I sort of began with the idea of like I'm talking to a generally technical software engineering focused kind of group, and that the AI part might be something that's part of your day-to-day, and yet it might not be. So that's why I'm going to begin with kind of level setting with talking about compound AI systems in general. And then closer to the end, I'm going to pick out a couple of features that Databricks offers that are one way to sort of tackle the challenges that compound systems bring to the table. And I love seeing the N8N demo up front, because a lot of the things resonate in terms of like, these are the problems that they're providing a low code answer to that you don't have to think so hard about in terms of getting that UI set up. Similarly, what we want to do is talk about how we're making certain things easier for you in terms of how you can get things done. So really quickly, just for the sake of this conversation, show of hands, how many people are working with AI tools on the daily right now? Okay, great, fantastic. That's a strong showing. And then for how many people is it something where like today is a day where you're actually starting to explore whether or not you want to mess with AI tools, but you haven't already done a lot of work with them? Okay, so there's a few people in that camp. So hopefully this is, again, not speaking at a level that's trying to, like I'm not trying to be like pedantic or anything like that. So hopefully this comes at a good place for you. We'll see how we do. Since you're here, you already know certain things around generally where AI is going. And one of the things I'm talking about here and introducing this notion of just speaking to the term compound AI systems is just to sort of say that, before this year, most people were focused on and looking at an individual model and saying, how well is that model perform? We were essentially looking for the notion of like a single AI model that could be trained to being so good in a general purpose way that you just need that one model and it could answer all the questions and do all the conversational or text-based or input-output things, switch to multimodal, all of that kind of stuff in one supermodel. And what's become relatively obvious working in this industry, and I'm sure you have seen, is that the best solutions, as you look into what's going on this year, the best solutions are not coming about because of a single model that has everything baked into it, but rather by the people who are exposing APIs, putting some additional complexity behind that and making a compound system that's actually delivering on the goals and promises of what we want out of AI tools. So when we talk about multi-part systems, what are we talking about? How does this break down? That demo that we just saw from the N8N demo was actually breaking down and showing like, here are the pieces that are involved, taking in an input. We have a language model that we're working with, and then there are specific tool usages and there's specific patterns that are being funneled through the process so that you actually know, okay, what I want to do is to connect to a calendar, connect to that API and retrieve things. Let the language model turn a text-based request into what function do I need to call and how do I make that API call to get the things that I want. You're familiar with that. That's what we're talking about. Whether you've used frameworks like LangChain or Llama Index, or whether you've used more helpful in terms of UI tools like what you just saw on the screen here. The idea is that you're connecting the dots between, I've got an LLM that can do great things in terms of understanding and then generating text that can be useful for me, and applying that capability to specific use cases that have been defined as part of your larger system. So that's essentially like the thing that I think there was a little window of time here where there was like people were just kind of continuing to say, for example, look at if you're looking at the leading benchmarks and you're looking at the like which models are ranking higher than others on the leaderboard, LMSys leaderboard or something like this. What you would see on those is that you might have, uh, Gemini and Claude Sonnet 35 and OpenAI GPT-4o or o1 and all of these things being directly compared against something like Llama 31405B or directly compared against Mistral. And the question that I always started running into, and I wanted to make sure that people were asking was, is this an apples to apples comparison? Why are you looking at a multi-part system that's actually very good at doing its job, but is just the thing behind that API, and you actually don't know what else is in it? And then saying, well, I'm going to deploy this single model and compare how well this model does. I just think that we kind of need to remind ourselves that even those systems that we're using every day, where we treat them like a monolithic thing, that there's actually the complexity hiding behind it. And at this point now, if you've been working with, say, for example, o1 or Sonnet 3.5, they're showing you, right? They're saying, like, here's the system prompt. Here's the chain of thought that we're encouraging you to go through to get the output back. Here are the data lookups that we're doing along the way. And like all of these pieces that are essentially the compound system that you can build as well. And the idea is as long as you know what the pieces are, then you can build a compound system as well. And you can tailor it to what your needs are, depending on what your application goals are. And this is a key. Once we understand that, then we can start getting into the space where what we're doing is applying the same engineering practices we know and love from having done software engineering, distributed systems development in all these other places, and get back to like being comfortable that like, okay, I can take the system, I can break it down into parts, I can look at and modularize this thing, and then look at each component, inspect it, measure it, these kinds of things, and know that what I'm getting back is not something that's coming out of a magical black box, but rather something that I've specifically engineered to give me something that I wanted for my application. So that's essentially like, if nothing else comes out, that's the most important thing I want people to remember about where we are with AI development. As marvelous and wonderful and magical as AI is, we can get ourselves back to regular engineering practices to be able to do the things it takes to develop the applications that we want with the reliability and observability and these other kind of things that we've gotten accustomed to looking for in the software development paradigms. So here we are, breaking down, like, we thought about this as like a simple static model before, and now let's talk about like the pieces that go into making something happen, right? So we talk about just looking at individual models, and we talk about the notion of prompt engineering. You've been feeding data into the prompt and then making choices about that, and then tweaking the prompt to tell the model, hey, no, I really want this response to be just like this, and can you please not say anything about that other thing over there, and so on, and adding that into the prompt. You can start thinking about RAG systems. You start thinking about, like, in essence, that next step of we're going to retrieve documents and then insert the document content, the document chunks into the prompt. So it's like a document-based prompt engineering. And then you can go farther into the space of talking about what agents are doing. And my favorite sort of shorthand for what agents are doing is that they remember state. And as you ask an LLM to generate something back, the LLM's pattern, its behavior itself is stateless. So you actually have to have that. So just even doing a chat interface that remembers the rest of your conversation, you're inserting state. That's an agentic kind of behavior. And then you're just asking the LLM to be the one to generate the next steps given the state space that you're in at that moment. So now you can say, hey, LLM, it's time for us to generate a function call. And you can do other things that are in this kind of space. And that's all still essentially like, remember where you've been, format the response in the way that I like. That's prompt engineering. Get the things that I need for the next step of this process. That's the agent remembering the current state of affairs and having a sense of the flow that you want to get through. So that's it. This is compound AI. This is just a way to talk about and remind people of what the pieces are that you've been working with already. So why do we care? Like, why think about this in terms of compound AI systems? Well, one, they work. If you've used the latest models that are out there, you see how good they are. Part of how they get there is through adding these multi-part components to solving these problems. Well, we found working with our customers, this is a set of data or set of statistics and numbers that come from a specific interaction that Databricks had with one of our customers. They started trying to solve a problem. The company's called FactSet, and FactSet has their own query language. They call it FQL because FactSet. And when their employees get started, or when people who want to onboard and use FactSet come on board, the first thing they have to do is learn FQL and start getting functional with that querying language. And they decided, well, what if we could just provide a natural language interface instead of FQL to help people get on board faster? And so they started down the experimental path. And this is the experiments, right? So don't worry about the numbers being fantastic yet, but is it going to do anything? Can we get somewhere where we start to see that we can possibly get positive results? So they started out with GPT-4 and they got 55% accuracy. It took 10 seconds on average for those responses to come back. And they're like, okay, well, let's see what else we can do. And working with Databricks, what we said was, well, let's break that down into smaller components and start to look at how we can refine and improve the process that's being done to translate a query into the language that's correct for actually running the FQL query. And that ended up being broken down into a couple of different pieces. So starting with a query processor step, and then retrieving information from the data set, classic vector database interaction, right? You got some embeddings and you can go and do a retrieval step. Then there was an LLM involved in generating some arguments to actually be able to pass in and stuff like this to add and to refine the query. And then the final formula, which includes the arguments that were generated plus some of the data that was retrieved and all of these things in terms of the categorizing the query itself and how to frame it up. And not only did the accuracy go up 30%, but the latency went down. And you can accomplish lower latency and ultimately lower cost in a lot of these solutions because when you're tailoring what you're doing with a multi-part system, part of what you can do is say, I don't need that big a model to achieve the same result as using the general purpose, full featured, very awesome, very amazing general purpose model. So you can then start talking about like developing and training specific models that have been tailored to your need, or just a smaller model in general purpose model might actually be good enough for your task right out of the gate. So these kinds of improvements are available to us, and as we engineer our solutions, then we can take advantage of those opportunities. So this is great. They can accomplish a lot of the things that we're looking for in making our applications what we need them to be. They are able to take care of accuracy issues, and because you can supply context from today and not worry about the fact that the last time the model was trained was 6 months ago. You can do verification steps to start with ground truth and compare it to what the LLM's producing, so that you can make sure that you got accurate responses. You can add some safety things, guardrails, and these kind of things. So with those opportunities, however, there are some sort of new challenges, some slightly maybe unexpected things start to happen where you think about new kinds of ways of that things can be inaccurate. And on a step-by-step basis, when you have a compound system, where did that inaccuracy come from? So if you start thinking multimodal and you have an image like this come up in response to the prompt, the prompt says, generate an image of a Viking, and then these images come back. And you have to say, that's not a Viking. So how do you catch that? And what part of the system is essentially like going to be the part to look at to make adjustments to account for that? And so that's going to be one of the things that you want to think about now that we're thinking about a more complex system, because it has more moving parts. So part of getting more moving parts to work better is to figure out places and ways that you can automate the kinds of improvements that you need. So DSPi is an open source library. Stanford NLP department published it, and it's available on GitHub. I'd be happy to share links for all this stuff. We'll make sure to have that in follow-up materials after the event. And the DSPi library's job is to automate the notion of prompt engineering by using a code style pattern for actually doing that work. So here, this is some Python code that you could write to implement a retrieval system. And what you're telling the code is, I've got a signature for a prediction here. So this predict call, basically the signature is just telling you I'm going to be putting, a question is going to be provided, and I need a search query to be the output result. And you just sort of define those at that level in this text-based way. And then if you're familiar with training models and you see it, you literally using the function call as the name is forward, it really, you can see like the way that they wrote the code, they were reminding themselves of like thinking about like a pattern where, with training models, you iterate and you get some kind of score, you compute some kind of loss, and then you use that loss to code to say which way do we need to tweak to improve. So the same thing applies to how it works. So what DSPi does is automate and uses sort of like what you call a compilation process to find and generate sort of an optimal prompt for a given model. But you can optimize that prompt for that model in a code-based way so that, like, say you swap out a new model, when you get to that next model, you don't actually have to change anything about your code to re-optimize the prompt for the new model. Since, as you know, different models have different idiosyncrasies. You run into like slight behavior differences between models, and that could be talk about like you were using GPT-4o Mini today and you want to try Claude 3.5 Sonnet, so you switch it over. That's something you want to be able to do without necessarily having to write a lot of code changes. This is a tool that can help with making sure that your prompting gets improved and optimized without having a lot of code changes. So a couple of details you can see about how this works. The generate query step is what we're looking to get out of this. We do the retrieving part involving the chunking as a standard in the context of a RAG situation. Some more examples that are supplied to say, like, this is the format of the answer that we're looking for. And it's part of how it optimizes what the prompt is going to ultimately be. And then what it'll help make the model actually generate the kind of response you're looking for. The next thing I want to mention as like a tool that helps in this space of working with complex systems is AI Gateway. What we're doing with the AI Gateway is essentially providing a proxy. And that proxy's job is to be able to give you the kind of control of what you want to do in terms of requests in and out to a given endpoint, whichever API you're using, whichever model you're working with, and be able to provide controls, rate limiting. You can do some things around observing what's going on, usage tracking. You can actually log these things. You can use this tool to actually have the ability to sort of do some routing. So for example, you might have the idea that you want your system to be more cost effective by using a lower cost model, when a lower cost model will generate a good enough response, but then evaluate the response that comes back and say, was that response good enough? And if the answer is no, then you could escalate and pass that request to a more expensive model. Question? The question is this low code? So there is a UI element for this so that you can actually enable it with the UI, but we also have an API so you can actually use code and an API call to get it done. So it's both ways. So this AI Gateway then means, again, back to the idea of like, I had one LLM that I was using for this process and now I want to try the next one because the new hotness is out. You can swap out the model inside the gateway, keep everything else about your application architecture exactly the same, and then be able to do comparison. Is the application behaving better with this model versus that one? So you can start to picture like doing things like A/B testing and other things like that to be able to say like, I'm going to iterate on my model without changing the rest of my application architecture, and make that easy to do without having any major alterations to the rest of the system. That's another feature in the idea. The idea is, in each case, how do we preserve the ability to do the modularity we want with building a compound system, and then be able to have the tools that we need to make sure that we can inspect how the work is doing and figure out when we want to make changes and what kinds of changes do we want to make. The next thing I'll highlight in the Databricks platform, and it's really kind of these all go hand in hand when you use them together, but they're also separable in the way in terms of like seeing the modularity. You can apply what you need where. We have this thing, the AI Agent Framework, and what the framework is about is providing both the ability to deploy the application, deploy a model, deploy an agentic tool capability. So it's very similar, actually, what you saw in the previous demo. The idea is you can deploy a tool, you can actually code up the tool in one place and then have it as an element that you can then refer to in the UI. You have the evaluation thing. One of the things that we've done in evaluation is we've built in a very easy to use LLM as a judge evaluation pattern, so that what you develop in terms of building your system, you can then have the responses automatically evaluated, and then given a sort of a golden data set that you would use for testing purposes, you have your eval set, you can automatically rerun all of the testing, all the evaluation against that eval set that you have set aside, and then score each of these components in terms of how your application performance is improving based on what you've changed. And so it provides some of that automated testing things that you've been looking for. And the way the agent eval is working with the LLMs as a judge, it does automate that and give you like some decent confidence in certain areas. There's obviously things that LLM as a judge can't solve on their own, which is why you will also have the ability in the system to surface up a head-to-head comparison between one solution and another for your human users to interact with. And then they can type a prompt in and evaluate what they get back from each of the different things and provide their preference feedback on how it's going. And that's a piece of UI that we also have available. And then this last piece here that's mentioned, this MLflow tracing for GenAI applications. The tracing part breaks down tracing the entirety flow that goes into a given tool or given to a given model. So you can actually see step by step. Here was an input that was sent in, the prompt that was sent to a given LLM. Here was the response from that prompt. Given that response, let's just say that what it was generating was a JSON blob that you want to send to an API call. When the tool sends the API call, it logs that call was made, and then it logs the response as well. And then it iterates through all of the steps in your, if you want to call it like a chain, it iterates through all the steps in your chain. And then you can look through all those iterations and see, for example, if you're trying to diagnose, where did this thing go off the rails? Where did it stop? Where did it stop staying true to the source data in terms of being accurate? You can find that point, and then you can say, okay, yeah, the inaccuracy is here. It's in the retrieval step. We're not actually getting the document chunks that we really want. Let's make sure we tweak how we're doing the retrieval. Maybe we need to do not just semantic similarity, cosine similarity search, but rather we need to also do like some keyword search, mix that in and do a hybrid search instead of just cosine similarity or something else. And you can see what you need to get done based on what each of the steps has been doing. So this is where the tracing provides the debuggability, the observability that you need to be able to manage a compound system. And this is the kind of thing, this is what Databricks is about, is providing sort of like a platform and building blocks that you can use to build and customize the thing that you want to get done. So that's basically it. Now I got really close to the mic and it got loud. Sorry about that, step back. So that's basically it. The idea is that once you're working with these systems, you want to be able to debug and analyze what's going on. And you want to be comfortable that you can apply the same old software engineering that you already know in this context, the same way that you had before. And once you sort of can demystify that aspect of it, then you're in a good shape for being able to make the application that you want with the accuracy that you need, and be able to verify that you're getting the results that you're after. All right, so that's about it. I've got some screenshots that we can skip to for in the Q&A part if there's an interest and a need, but I would love to get some questions if you have some. So what I have right here in the slide deck is a couple of screenshots. I did not bring a live demo because I'm a little gun shy with live demos that end up going south, but I can pull up a couple of screenshots just to sort of highlight what we're looking at here. So this section here, this sort of notebook style interface, is a place where we're inserting actual code to write that's going to become a tool in the system that you can then sort of use and connect to. So once the function's been created, and you can see that they're putting in the example. They have two different examples. One was Python code, and this one's now SQL. But in each case, you write the code for the tool on one side, and then once you have it available in the UI, you can then select it and use it in your agent-based sort of chain setup. So then the chain interface is something you're going to see a little bit more in a different place, but this is the idea. You can see the tool setup there. So here in this UI, what you're seeing is the tool that you wrote in the first step being added to the users to the playground interface that we have, and there in the playground you're actually setting up for you to be able to actually send in a prompt and then watch the behavior happen. So the playground interface gives you that place. Type in a prompt. Given that you've leveraged a particular tool, you select it from the drop down, and you can select multiple, and then sort of walk through and see what happens, and see if you're getting the behavior that you want out of the calls. The other nice thing about the playground is that once you set it up in the playground, when you want to get code from that, we have an extraction button for being able to extract the thing as a notebook. So then you have all the code. Top of mind quickly, like what I would love to do is in the DevRel team, we have notebooks that we've published just to show example code and show things built out in published notebooks. And I'd love to point you at our DevRel examples and then start from there. So
Cool.
that's notebooks.databricks.com/DevRel. And again, I'll add that as one of the links to share post event so that you can have it. Yes, it's tied into Unity Catalog. Very excited that you mentioned that in the specific, because it's an important element of what we can do in this state, is to provide the governance consistently across all the things. So just like when you register a model with MLflow, so the MLflow part, all of the things. So when looking at the Databricks platform, a lot of the pieces that we're talking about here are the Databricks hosted version of MLflow. Now, the functionality is essentially the same in terms of MLflow open source versus MLflow integrated with the rest of the platform. But the reason I mentioned that is to say that what I'm saying right now about MLflow registering a model, one of the patterns that you have inside of the workflow is that you go through the process of training a model or finding and sourcing a model from Hugging Face or what have you. And then you do a step where you actually register that model, and then its registration, you're registering it into Unity Catalog. And that then gets it in the state where it's ready to be governed and managed by Unity Catalog in terms of access controls and things like this. Some things also become like automatic inheritance from that. So if, for example, you've been working with a particular data set and that data set was used to train or fine tune the model, then the access rules that apply to the data set now apply to the model as well. So it's inherited through the same relationship within Unity Catalog for that. So some of those patterns are things that we have baked into it. And then, of course, as the administrators of the instance have the ability to do, you can change through the Unity Catalog interface, who has access and what access rights they have. So the governance part is included. It's more like you inherit the permissions from the person who writes it. So the access rules that the person who writes the function has, that's what will be inherited for a function being written. And then when it comes to the use of that function in the context of a given agentic system that you're building, you're defining the chain, you're defining the flow and the steps that you want to occur in the context of building it. So it's sort of a little bit less arbitrary. Like you actually do define, like, I want this one to be called, and then I want that one to be called, and so on, and iterate on those to get through the steps of it. But it is something that, like, that access is defined in how you build the process in the framework. One of the things that you'll find is that given an agent that has been defined in the system, if you have access to that agent and you want to set up for your new agent to be able to call that one, it'll be dependent on whether or not you have access to it at the time you try to implement that and set up that linkage in the system. So that's kind of where you typically sort of see those things come about, because again, those once one person has written that agent within the platform, then it's available and visible with the access rules based on their visibility.